Hi, this is Priya from CSE Department, Priya Institute of Technology. This video is for BCSE students, 3rd year, 6th semester, Regulation 2017. And the topic is from Compiler Design, from the Unit 2, which is Syntax Analysis. And the topic that I am going to discuss is LR Parser. So in this video, I will be telling you the introduction of LR Parser. In the forthcoming videos, I'll tell you how it actually works. Let's get into the topic. Introduction to LR Parser. So before knowing about the LR Parser, you should actually know where does LR Parser comes from. So for that, you need to know the types of parsers. So the first types of parser. So parsers are actually divided into two categories, which is top-down parser and bottom-up parser. Top-down parser is of two types, which is LL1 parser and recursive descent parser. Similarly, bottom-up parser is of two parsers, which is operator precedent parser and LR parser. So we are going to study about LR parser, which actually comes from bottom-up parser. So let me tell you the types of parsers, LR parsers now. LR parser is divided into four categories, which means there are four types of LR: LR0, SLR1, LALR1 and CLR1 parser. So SLR is nothing but simple LR, LALR is nothing but look ahead LR, and CLR is nothing but canonical LR parser. Coming to the power of precedence, this LR0 parser has the least power, and CLR1, which means the canonical LR, is most powerful among all the four parsers. The next is the architecture of LR parser. So as we all know, the parser uses buffer and stack. Input buffer is for storing the input string, and stack is used for pushing and popping the input string according to the parsing. So LR parser make use of LR parsing table. So when you look at the four parsers, the similarity is these four parsers will make use of buffer and stack, same buffer, same kind of stack, whereas they differ only with the parsing table. So that is what I'm going to tell you now. So all the LR parsers, they make use of same kind of buffer and stack, and the only difference between all the LR parsers is parsing table. They differ only with the parsing table. All other things that you are going to do is same. So now LR0 parser and SLR1 parser uses canonical collection of LR0 items. I want you to note this. LR0 and SLR1 make use of LR0 items, whereas LALR and CLR1 uses canonical collection of LR1 items. So before entering into the LR parsers and its explanations and its problems, you need to know some of the keywords that is used in LR parser. They are augmented grammar, closure and goto. First let me tell you what I mean by augmented grammar. So augmented, let me take a grammar first. S tends to AA. So this is my grammar that I am going to take. What is augmented grammar in this sense? Here S is my starting symbol, right? So I am going to add a dash to S and I am going to make a new production. So S tends to, yes is my starting symbol. The same starting symbol I am adding a dash and it becomes an augmented production now. So what will be my augmented grammar? S dash tends to S tends to A. That is what the original grammar, right? So this is augmented production and the original grammar is this one. So as a total, now this becomes an augmented grammar. Okay, next is closure. So closure, let me take an example grammar first. S tends to AA and A tends to small a, capital A. So let it be an example. I am going to form closure for this particular grammar. Closure is nothing but S tends to dot AA and A tends to dot AA, which means the difference between these two grammar is I have just added a dot sign in front of the production. So this is my plain grammar and this becomes my closure, but just adding a dot sign to the right hand side of the production. So this is called as closure. And the next one is go to operation. Take an example. S tends to AA. Consider it as state I naught. I naught is nothing. I am considering this production as a state, and that state I have named it as I naught. So my target is I have to move this dot sign to the next position. So how can I do that? I have to traverse through A or traverse across A so that the dot can be moved to the next position. So S tends to A dot A. So when I can get this, when I traverse it through A, when I traverse through A, when I migrate across A, I will move to the new production called S tends to A dot A. The dot has been moved now. So I am going to name this production, say for example, I1. I am going to name the state of this production as I1. So what actually happened here is, on state I0, on applying A, which means on moving A, or when I am moving across A, I am moving to a new production or a new state called as I1. I0, on migrating through A, I am moving to a new state called as I1. So this is my go to function. That is, on I0 upon A, go to I1. So this is my go to function. So these three are the keywords that you should know for solving the LR problem. So this is all for the this video. I'll discuss about the LR0 and SLR1 parser in the next video. Thank you.